Alright, in this video we're going to work on getting a single piece of information out of the database. We're going to just recall the records that we already had in there. We're going to do this by accessing their primary key and using the get function on the document client that we used to put the information in there earlier. So let's go ahead and jump in and take a look at how that all works. Now that we've got some data into the system, let's go ahead and get some data out of the system. Here I'm going to create another POC class. Let's go ahead and call this one DynamoDB query single POC. So we're going to be focusing on querying a single record for this particular POC. And again, we have other POCs that we can benefit from. So let's go ahead and copy and paste in everything from our last one and then eliminate the parts that we don't want. We're not going to be using any UUIDs. We don't need to create one up front. We do want the DynamoDB, but this is going to be different. So one thing I like to do is not to have this stuff around so that it doesn't mess up our understanding. So I'm just going to delete it and start fresh, and I'm going to call the get method this time. So everything is pretty much fundamentally the same except for that we're calling get now. So let's go ahead and make our comments work like that. Okay, now that our logging matches, let's go ahead and take a look at what it wants. So again, I'm using IntelliJ, control space, and it's going to tell me these things. If you're using Cloud9 inside of the browser or some text editor that doesn't support this, a great way to do this is to just keep a copy of the documentation open. In fact, I'm going to go take a look at it right now. Also, one nice thing is they provide an example code right here at the top. We're doing things a little bit differently with promises, and we're using a more modern version of JavaScript. However, this is still very useful. So it often shows you a very minimalistic example. So in this particular case, it wants us to use table name and pass it a key. So let's go ahead and bounce back to IntelliJ, and I'll go ahead and hit control space and table name right there, boom, colon, and we know that that is test. And then the next thing it wanted was key. So the key is going to be based on what you set up. In our case, UUID is our key. So I'm going to pass it a UUID that I know is in the database, and it should return me that record. So bouncing back to our DynamoDB console, we will find a number of UUIDs that should work for us. You'll need to copy your own so that it matches your databases. Ours will not match, so I'm going to go ahead and put that guy in there, and then I am going to go ahead and copy and paste this, and let's go ahead and create a function for it over here on Lambda. Now, before I go ahead and test this, I already know that it's going to fail when it tries this. So let's go ahead and preemptively go back over to IAM and fix that. And here, it would have complained about get item, even though the method is called get. This is one of the problems with using the one-off APIs like Document Client, is sometimes it doesn't match. However, if you had just run the code, you would have gotten a very specific error that would have told you about that. So we'll go ahead and click this, and we'll save it. Now let's go ahead and create a test and run the test. Bounce over to see our logs. And there we go. We successfully retrieved the information that we put into the database, and it's returned us all of the item that we, or all of the fields from the item that we put in there. So there you go. That's how you get something from the primary key. However, that's not the only way to get stuff, and often isn't enough for us to write a complete application. This assumes quite a bit. First off, it assumes that we know what the UUID is. So in our real code, we're not going to have that luxury, so we're going to need to query things out of there, or get everything, or query to see if the labels response has something that we're expecting in it. So in the next video, we'll go ahead and take a look at that. I'll see you over there. So there we go. We got a single piece of information out of the database, but we needed to know its UUID. This is just not practical in all circumstances. Whenever possible, you should definitely be using this function to retrieve a single piece of information, because it's the fastest way you can look up something is by its primary key. However, in the next two videos, I want to introduce you to two different techniques called scan and query, which will return multiple pieces of information based on a query structure. So let's go ahead and move on to getting multiple pieces of information out of our database. So now it's time to try and get multiple pieces of information out of the database. The way we're going to do this is with the scan method. There's two types of ways to do this, and we'll go over both of them. However, in this one we want to focus on what it would take to just use the simplest way. This is often really good when you have limited numbers of records in your database, or your project's rather small, or doesn't really care about performance. So let's go ahead and take a look at this. Alright, in that last video we took a look at getting one thing out of the database by the primary key. Let's take a look at there's two different ways to get multiple records out of the database. Now, they're very different and they work very similarly though. So what's different is behind the scenes there can be quite a bit of intense processing that goes on if you're scanning through millions of records. And scanning is the first technique that we're going to look at. So let's go ahead and create ourselves a POC class as we have done before. And right click, file. Sometimes my naming gets a little verbose, but I'd rather understand what it is than try and figure it out later. Okay, so here again, we're going to just go ahead and copy one of our previous ones. So we'll start with the DB query single, and we'll copy all of that over. And this is going to give us most of what we want. Again, I always like to make sure I delete stuff like this right away so that I don't accidentally call it with just some junk parameters from something else and cause some damage. So we'll also make sure that our logging looks good. All right, and it's that quick. Okay. Next, we're going to go ahead and add the parameters into our call. So I know we need table name. Just every call ends up needing table name. And now the next part is to pass it the parameters that we want to scan for. So let's first go over to our DynamoDB and see what we could query for that would return multiple records. So here we see we could query basically any of these fields with scan, but none of them are going to really return us only a subset of these. Like if we query for this image name, we'll just get one record back, which is great, but you know, we want multiple records back. So I'm going to query for faces detected equals true, but first I want to add a couple of falses here. Let's go back to Lambda and go back to our function that creates records. And let's create some differentiation in the data that we have. So I'll add false and change these to 4. And I'll go ahead and test it. And let's go ahead and create one more. Also with a false. And I didn't click save on that last one, so we're going to have some weirdness in there. So we'll go ahead and click test. And now if we go back over here, we should see that I have two label 3s. So that'll work. We can query for this for uniqueness. And then we can also query the faces detected. So let's just go write those two queries real quick and see what it looks like. Okay, this next part can be a little confusing at first, but I think it will make sense in the end. So the way this works is we are going to write what is called a filter expression. And in there we will have placeholders for our field names and our field values. And then in other parts of this variable, we will add to it the actual representation of those things. So we'll refer to the variable name that is in the filter expression, and then in two sub-objects we will say what each of those tokens actually means. So let's go ahead and write it and review it. So here I have created the faces detected equals variable, in this case colon faces detected. So in this case I can refer directly to the name faces detected because it's not a reserved term. The reason that we have tokens for the names as well when you need them is so that you can avoid stepping on the reserved terms that are part of DynamoDB. It's a little annoying, however, if you run into one of them, it'll give you a pretty clear error. So don't worry too much about it. If you ever run into that, it'll be pretty easy, and we'll go over it here quickly in this video as well. So let's go ahead and continue with this. So in this case, I want to look for faces detected being true. So from here, we'll go ahead and copy this over into Lambda and give it a try. So as usual, we'll create a function. And in this case, I've already created the function when I was filming a different take earlier that did not come out so well. So we'll go ahead and do this. And we'll notice that I've already set it up. I didn't set it up any different than the previous ones, but you'll notice that I only wrote about half the code and then took it over here to test. So now we'll go ahead and add in the rest of it. Click save. Let's give her a go. Now in this case, I'm going to look at it in a little bit different way just to kind of show you guys that there's multiple ways to see this. So down here you can see the execution results. This might actually be easier, especially if you're using Cloud9, than going over to the CloudWatch. And here we go. We have multiple items and it's an array. And what I'm going to do is copy this JSON into my clipboard and I'm going to take it back to IntelliJ. And here I'm going to show you one of my favorite features. If you hold Control, Shift, Alt, and Insert, or use the function Create New Scratch File from the menu, you can go ahead and create a JSON file and then paste it straight into here and then hit Control Alt L. And this can also be done by highlighting it and formatting the code. So what this does is just makes this much easier to read. So we'll notice that faces detected is true in all cases. And it even tells us some metadata about the query, like how many were returned and how many were scanned. So this would be useful if we were creating a search results screen. We could show 4 of 5 available records meet your criteria. And notice that this is just a scratch file. They're created automatically and given a name, and then you can just close them without ever saving them. However, they're all going to be saved down here, so if you need to go back and grab one, there you go. Okay, so that's scanning. It does have some performance limitations, but those performance limitations kick in a very, very large number of records. For our application, we could use this all day long. We're going to go over both of them because the second one is very important if you have a common query. So that one is called query, and it requires a few other things. So let's go ahead and move into the next video and start looking at the other way we can get multiple pieces of information out of the database. Okay, in this video we're going to set up a query method, which is a lot like a scan method from the last video. It retrieves multiple records, but in this case it does it in a hyper-performant way. You can even provision its own read and write capacity. So let's go ahead and jump in and talk about some of the prerequisites that you're going to need to set up to make this all work. So before we actually get into using the query function to capture multiple records and process them, we need to talk a little bit more about the extra requirements that come with using query in DynamoDB. The first thing that you need to know is that query is much faster than scan. And the reason for this is that queries require an index. For those of you that are familiar with indexes from relational databases or other NoSQL database platforms, they're largely the same here. For those of you that haven't, what an index will do is it takes the data that is inside of a table and organizes it based on a specific set of columns that you identify. And it organizes it in a way that makes it more responsive to queries. So, for instance, if you say something like, I want to index based on a date field because I want to do lots of date range searches, it would arrange the data in order of the dates, and then it would keep a file on the side that says each day starts at X spot. And then that way, instead of having to look through all of them, or scan them if you will, it will just know that I can go ahead and look at this point in the file because I know day X starts at this file point Y, and then I can reasonably assume things are in order and go find my thing much quicker, and then it'll return it to you. So this is the advantage of an index, but it requires a little bit more work. So as we've already talked about, indexes make queries go much faster. However, they need to be set up. We'll need to set up something called a GSI, or Global Search Index, for the table that'll specifically tell us about the fields that we want to organize. It requires its own provisioning as well. You actually scale the reads and writes to be separate from the rest of your table. The reason for this is you might have a high read or a high write provisioning on this index, and your database may subscribe to a much different usage model. Also, different indexes will be used in different amounts, so this will allow you to provision the proper amount of processing power while keeping your costs low as you start to identify specific areas that are going to require an index. So the last thing I'd like to mention is that queries can be created as needed. In development, you can use scans, and then later you can switch to queries as you need to performance tune your application. This will become especially important in large-scale public applications. So, for instance, you might start with scans, and then when you launch to your QA and beta environment, you might notice that it slows down under certain conditions. And then you can go switch out the scan for a query very easily. In fact, let's go ahead and start taking a look at the syntax, and you'll see how similar it really is. All right, and back to our IDE. We're going to go ahead and copy, just like we have on all of the previous ones, the one we've been working with. So in this case, in the last video, we did scans. So in this one, we're going to do query. So first things first, I'm going to go through this and kind of explain what's going to change and what's not. We're going to call query instead of scan, and instead of filter expression, it's going to be key condition expression, and that's going to be based on the index that we're going to create here in a minute. And then this part is the same. So overall, most of this is the same. We're also going to be adding one item. And then down here, we'll change this to query just to make our logging a little clearer. And everything else is going to be the same. So you could see where in production, this would be very easy to change when we go to a production environment where there's a performance concern. So as we know, security is going to be a concern. So instead of calling scan, we're going to be calling query. So we need to update IAM to accept that. So let's go ahead and bounce over to our browser. Okay, here we are in IAM, and I'm going to go down to policies, and we will adjust the photo cloud policy per usual, except for we're going to do this a little bit differently. I'd like to show you a little trick for editing the policy that makes this much quicker. However, this change is usually only good if you're making a small change or you have the JSON in mind for your security policy. So what we're going to do is we're going to click on this JSON button, and it's going to show us the JSON that would be used to create the policy summary that we look at over here. So looking in here, here are all the items that we've given permissions to, but it's in the programmatic format that AWS uses internally. And really all we want to do is add very slightly to this. We want to add the DynamoDB stuff that we need in here. This JSON file is in the same format as we've already looked at. However, it's being used for a different purpose. In this case, it's being used to secure our Lambda function as opposed to provide an access policy to SNS or anything else we've used it for. So I'm going to scroll down and find where it says DynamoDB. Now, your JSON file is not likely going to look the same as mine. It's going to have all the same permissions if you've been following along. However, the visual editor really honestly just destroys the JSON formatting and creates a whole series of things you just don't need, and that are basically duplicates of each other. For instance, this is largely a duplicate of what this is in meaning. So here we're going to just find wherever your DynamoDB settings are, and that's where we'll be making our edit real quick. Now let's go ahead and click Edit Policy, and then instead of editing here where we usually do, we're going to bounce over to this JSON tab, and we're going to scroll down here, and we're simply going to duplicate any of these line items that you want, and instead of saying whatever the second part is, you're going to put query. So this gives us permission to the DynamoDB system and the query. And specifically, it's limited to the resource test, which was already set up. So now we can just go ahead and click Review Policy and save the changes. And there you have it. We've updated our setup and we're ready to go. Next up, for this to actually work, we need to tell DynamoDB about the index that we're creating. So we're going to go over to DynamoDB, and I'm already here in our test table. And what we want to look at is the Indexes tab this time. So here we actually have a really nice statement that wraps up what indexes are. So let's just read it real quick. Global secondary indexes allow you to query efficiently over any field or an attribute in their language in your DynamoDB. GSIs can treat any table as a key, even attributes not present in all items. So this means that we can query anything we want performantly. So what we're going to do is set one up based on our code. Here we have our new function, and I want to go through and make some modifications to it so that it is a little more interesting. So let's go ahead and make some changes now. Okay, there we go. That's going to give us a little bit more of an expressive query here. So let's take a look at what we did. Bucket location equals : location. So : colon location is a variable, and bucket location is directly from our table. And then down here, I say location is this, just like we did with scan. One of the only things we're going to need to do now is change filter expression to key condition expression. So let's do that right now. So there we go. Now we're ready to actually use a query with this key condition expression. Now there's one more variable missing from this whole thing, but let's come back to that in a moment. If we go back to our browser, we can now create the index that we'll need. And then this will give us the name that we need to put into our code. So let's go ahead and create an index. And in this case, I want to index based on bucket location, which is the same thing that we used inside of our code just now. And I'm going to let it auto name it. I really like this particular naming standard, so I'm going to copy this. However, you can change it to whatever you like. And it's automatically already set up for 1 and 1. This is the separate capacity that will be used to process just these queries. So when you send a query to a DynamoDB table, it will either bill off of your primary or use your primary capacity units, or if you're using an index, it'll use that index's capacity units. So we're going to keep all of the same auto scaling requirements since we don't really have anything in this project that we need to. And we will go ahead and click Create Index. Now this takes a little bit of time, so let's do some video editing. Okay, and there you have it. Our index is created. So notice again it has that its own read and write capacity, and this is separate from the read and write capacity up here. So we have 1 and 1 here and 1 and 1 here. So if we go back to the dashboard, we'll actually notice that we have provisioned 2 and 2. So back here in our code, let's go ahead and add the final little bit of magic sauce in here to tell it what index we want to use. So the index name is going to be bucket location hyphen index. So there you have it. Now we are saying go use this index to query this table to get this information using these parameters. So let's go ahead and see if I've managed to do this all correctly. We'll go ahead and copy the whole thing here, and we'll bounce over to our browser and back to our trusty Lambda creation screen. We're going to go through and we're going to do all of the same things that we've been doing before, which is to just create a function that is named after our file, and we'll be using node 8, existing permission, PhotoCloud role, create function, and here we go. So let's go ahead and come down here, paste in our code, and I want to just show you one thing that will likely be different on your database just depending on how you did your inserts. I have multiples of image 0003, so if I go back over to DynamoDB and just take a look at my items, I can confirm that I should get 2 records back, this first one and this last one. And here we go. So let's go ahead and come down here, paste in our code, and I want to just show you one thing that will likely be different on your database just depending on how you did your inserts. I have multiples of image 0003, so if I go back over to DynamoDB and just take a look at my items, I can confirm that I should get 2 records back, this first one and this last one. So let's go back to Lambda and let's go ahead and save our function changes. Let's go ahead and create a test. Let's see, something new, yada. I like yada. All right, and let's go ahead and click test. Now we're gonna get a new error here. So the error that we're getting here is that we are denied access on this specific resource. So let's take a look at what this is. It is the resource that is the actual index. So we have to give permissions to specific indexes. Now, this might seem a little over the top. However, there is a good reason for this. This will allow other people from other farms to query your indexes and be billed separately for them or scale separately if you ever get into a business to business type situation where you need to do that. So I'm going to go ahead and copy this real quick, and we'll bounce back over to IAM and edit this once again. And again, I'm just going to go straight into the JSON, straight down to here, and I'm going to change this to a resource array of strings so that I can add in a second string to this guy. And this will give us access. Again, notice that this is a nice, fast way to do things if you can just get used to the syntax. It takes a little while, I will admit. So here we go. We're going to review the policy. We're going to go ahead and click Save the Changes. We're going to delete the oldest version. And let's try this again. So I'm going to clear the old results here. And I'm going to just click Test again. And now it looks like we have a query result. So there is 2 results, which is what we expected, and the scan count was only 2, which means it only had to look at 2 records to determine this. Now, if we had 1,000,000 records in there and we called scan, this would read very much differently. However, with a query and a GSI setup, we are set to have a very performant query. In fact, look how fast this query executes. And this is with loading up Node, querying the database, getting the results back, and sending them to you. The actual query probably took only a millisecond or 2. In fact, you can monitor all of these kind of things from the metrics here. It's not showing up yet because it hasn't had enough time, because these metrics are delayed by about 2 to 3 minutes on average, I would say. Sometimes less than a minute, but most often at least 1 minute. Okay, as you can see, queries are very powerful. They're very similar to scans, and you can switch from one to the other without much work. So even though there's only a little bit of setup required for queries, don't change everything into a query. Otherwise, you're going to end up paying a lot of money for all your provision capacity when you don't really need to. All right. This is the end of Chapter 5. So now we're going to get into building the application a little bit more. We're going to start storing some of that data that we're getting from recognition into our DynamoDB, and then we're eventually going to build a full-blown front end that allows us to search our Photo Cloud photo library. Let's get into it. I'm really excited to take these final steps with you.